Good day. Today I'm going to show you how to deal with dy over dx if you are given y is equals to something, right? So dy over dx means derivative of y with respect to x. So let me just give an explanation of what this means. So usually if you're given, let's say f at x is equals to, let's just say 2x plus 2. When they ask you to find the derivative, you would say f prime x. F at x is the same as y. If you are given y and they ask you to find the derivative, it just becomes dy over dx, right? So if you're given y and they ask you to find the derivative, is dy over dx. The same way if you're given f at x and they ask you to find the derivative, is f prime x. So that's just what it means. So if you find the derivative of y, when you find the derivative, you write dy over dx. So we'll get deeper into it. So before we deal with various activities, we're going to deal with different activities on this. I want to first show you the skills, give you basic skills that are needed in order to solve this. So let's deal with one of them. Let's say you've got something like 3 over x squared and you want to turn this into a non-fraction. So if you want to turn this into a non-fraction, this will go at the top. But notice, because this is the numerator, this is the denominator. So for it to become part of the numerator, the exponent has to change the sign. So if it's positive, it will become negative, right? So another example, let's just say you've got something like this. Let's just say 3x and you've got something like this. So if you have something like this and you want to change it into what we call a differentiable form, a differentiable form is anything in the form of ax to the power of n, right? So for us to be able to derive something, it has to be in this form, right? We cannot derive something when it's in a fraction form, right? So it has to be in this form. We have to have a coefficient, a variable, and an exponent for us to be able to derive it. So this is what we call a differentiable form, right? So if we have this, it's not yet in a differentiable form. So for us to put it in a differentiable form, all we have to do is just to shift x, right? So when it's on top of the fraction, we don't have to change the sign. So all we have to do is just to write 3 over 4, and then we have to write it in this form. So what I did was just to shift it, right? But if it was down and then I decided to shift it, it will change the sign, right? So just remember that. So whenever something's up and you just want to shift it aside, you don't change the sign. The sign of the exponent remains the same. But if something is down and then you decide to shift it on the side, the exponent sign has to change. So let's deal with this first exercise. So they said find derivative of y with respect to x if y is equals to 3x squared minus 2 over x, right? So what you do is that you'll still write y because we're not yet deriving. Okay, why can't I derive? Why can't I just derive this and deal with this later? You can't do that. If you derive something, you have to deal with everything at the same on the same time. So if I derive this, I have to derive this. So since I have to change this because this is not in a differentiable form, so I have to put it into a differentiable form for me to be able to derive everything, right? So this is what I'm going to do. I'm just going to write y. As long as we're still manipulating something, we still write y. But when we derive, that's when we write derivative of y with respect to x. So we're still going to keep this the same. And then now let's manipulate this. So this is a denominator, right? We want to shift it on the side. So if we want to shift it on the side, it will become x, and the exponent is an invisible one, so it will become minus 1. So now I have put this into a differentiable form. So now that everything is in a differentiable form, I'm able to derive. So since I'm able to derive, the same way when it's f, when we derive, we write f prime x. It's the same way when it's y, when we derive, we just write derivative of y with respect to x, right? Or you can say dy over dx. So now we know that we have to multiply this. So what is 2 times 3? 2 times 3 is 6. And then we have to subtract. So 2 minus 1 is 1. So we don't need to write x to the power of 1. And then this side now we have to multiply these two. So negative 1 times negative 2 is positive 2. And then now we have negative 1 minus 1. Negative 1 minus 1 is negative 2. Just before I continue, if you want to be tutored, either online or physically, online it doesn't matter where you are or which country you are at, you can still be tutored. So we offer cheap online lessons, and if you want to be tutored physically, we can still make an arrangement. So call or WhatsApp this number, but preferably please WhatsApp this number, and then we will take it from there. So what I do is that I tutor people 5 days a week online, and I give tests once a week so that I can check your improvements. And then from there, we can leave it like that, we get our full marks. But sometimes the question can say leave your answer to positive exponent. So if you have to leave your answer in positive exponent, there's an extra mark for it, right? So this is negative, so now we have to change it to positive. So let me show you another skill. Let's just say we have this. If we write it in fraction form, this is over 1, right? So this whole thing will be a numerator. So when we want to change the sign of the exponent, if it's a numerator, it will become a denominator, or if it's a denominator, it will become a numerator. So for instance, this is -2, so I want to change the sign. So because this is a numerator, I will have to make it a denominator. So then we'll have the final answer as 4xz all over y to the power of -2. Notice I shifted it. It was a numerator, but now it became a denominator because I want to change the sign of an exponent. So if an exponent is negative and you want to change its sign, then it's gonna change from either a numerator to a denominator or a denominator to a numerator, depending on what it was before. Here is another example. Let's just say this is positive 4, right? So if I want to change the sign of this exponent, let's call this z. It's not 2, let's just say z. So let's just say I want to change the sign of this. If I want to change a sign of this, it means since this is a denominator, it's going to become a numerator. So therefore it will be 2xyz, but now to the power of -4. So it was positive, then it became negative. So the sign will change when something changes from a denominator to a numerator or a numerator to a denominator. So let's proceed with this. So we have derived it, right? But now let's say the question says leave your answer to positive exponent. Of course, with questions like this, there are worth 4 marks, but let's just say the question says leave your answer to positive exponent. So since this is negative exponent, we have to make it positive. But if we want to change the sign of something, it will change from a numerator to a denominator or a denominator to a numerator. So since this is part of a numerator, because this, when you look at it, is actually 2x to the power of -2 over 1. This is the same as over 1, right? 5 is the same as 5 over 1, right? So let's proceed. So since this is a numerator, as part of the numerator, we're going to make it a denominator, and the sign will become positive. And that's there we have it. Alright, here is an example. So let's just say they say find the derivative of y with respect to x if y is equals to 4 over 3x squared. So at this stage, is this in a differentiable form? Nope, it's not in a differentiable form, and these things would always come out in the exam where something's not in a differentiable form, then you have to make it into a differentiable form. So this is not in a differentiable form, so what you have to do, so from there, we have to change it into a differentiable form. So remember, we have got x at the bottom, right? And we want to put it on the side so that we can make it a differentiable form. So if we want to make it a differentiable form, if something is down, remember the exponent sign will change when we take it up. So some people try to take the 3 and put it up and make it 3 to the power of -1, but you don't need to do all that. All we have to do is just to separate the variable, because what we need is to have the coefficient, the variable, and the exponent. Then from there, it's in a differentiable form, right? Anything that is in the form of ax to the power of n, right? So now that we've made it into a differentiable form, we can now derive. When we derive, that's when we write the derivative of y with respect to x. Then this 4 over 3 times -2 is -8 over 3. If you don't know how to deal with fractions, you can just use the calculator. So then we have -2 minus 1. -2 minus 1 is -3. And then we can leave it like this, but let's just say they want you to put it into a positive exponent. Let's just say they say leave your answer into a positive exponent. So then from there into positive exponent. So from there, since this is negative and we want it to be positive, since it's up, we're gonna put it down and it's gonna be negative. The sign will change. Since it's negative, it's gonna be positive, I mean. So yes, that's what's gonna happen, right? So when something is on the side, it's the same as though it was a numerator. So if something is on the side and we want to put it as a denominator, the sign will change. Or rather, if we want to change the sign, we'll have to make it a denominator. Alright, here is another example. Let's just say derivative of y with respect to x if y is equals to 5x minus 2 all squared, right? Is this in a differentiable form? Okay, of course we can talk of the things inside are in a differentiable form, but the whole thing is not in a differentiable form, right? If the whole thing is a fraction or if the whole thing is in brackets, it's not in a differentiable form. So we have to deal with it. So from there we can expand it, right? But I like using the shortcut with this, but for now let's just expand it just for the sake of most people, right? Let's just expand it. So when you expand it, this is just gonna be, but you can choose to multiply, right? I'm just gonna use the shortcut. Okay, so the shortcut is gonna be 25 x squared, and then 5 times 2, 5 times minus 2 is minus 10, then times 2 is minus 20x, and then this is gonna be 4. Okay, I'm just going straight to the point, right? But yes, you can choose to multiply throughout and stuff, right? So but there's no mark for that. Yeah, so there's no mark for that. Yeah, there can be a mark for this, but not for that long step. So what they care about is this step. So notice I wrote y all over. I didn't write derivative of y with respect to x because we were still manipulating. When we're still manipulating, we still keep it as y. But once we derive, that's when we write derivative of y with respect to x. Then from there, 25 times 2 is 50. And then 2 minus 1 is 1, so I don't need to write 1. I don't need to write to the power of 1. And then this side is just going to remain 20. And then the constant always disappears. So there we have it. Alright, here is another example. So find the derivative of y with respect to x if y is equals to 4 over the cube root of x squared plus the square root of x over 2. So this is not in a differentiable form, so I'm still going to write y because I haven't yet derived it. I'm still manipulating. So whenever you have got, this is called radical, this square root kind of thing, it's called radical. So whenever we've got a radical, we have to convert it into exponential fraction. When we convert it to exponential fraction, whatever is inside comes on top, whatever is outside goes down. Then we're going to have exponential fractions. And then we have to do the same for there. Whatever is inside is an invisible 1. Whatever is outside is an invisible 2. Square root is an invisible 2. So then whatever is inside goes on top. Whatever is outside goes down. And that's what we have. So then from here, we have to still put it into a differentiable form. So we're going to say, so now this is down and we want to put it aside. So if we want to put it aside or we want to put it up, the sign will change. So it's going to be minus 2 over 3. And then this side, this is on top. So if you want to put it at the side, it's the same as it still remains on top. So we don't have to change the sign. But if we put it on the side, there's an invisible 1 here. So since there's an invisible 1, it will be 1 over 2. Then we have x to the power of half. The sign does not have to change because it was on top. If it's down, then we put it on the side. That's when the sign has to change. So far, this is what we have. We haven't yet derived it. We have turned it into a differentiable form. Then from here, let's go further. This is going to be, so now here we're going to derive. So since we're going to derive, it's going to be derivative of y with respect to x. Okay, then from here, this becomes, now we're going to have negative 2 over 3 times 4, which is negative 8 over 3. Negative 2 over 3 minus 1 should be negative 5 over 3. So you can just verify that part. I'm not using a calculator. Okay, so then this times this should be 1 over 4. And then 1 over 2 minus 1 is minus half. Alright, so we have derived it. We get our full marks. But let's just say they want you to keep your answer in positive exponents. So let me just write that in the next step. The previous step. Okay, so now let's write it in a form of positive exponent. So this is going to be derivative of y. So derivative of y with respect to x. And then now, this is negative exponent. So for us to make it positive, since it's a numerator, remember when it's on the side, it's the same as though it's a numerator. So since it's a numerator, now when I change the sign, it has to become the denominator. So it will have to go down. So then it's going to be 1 over 3. You can even change it back to radical form. Okay, so, but what matters is that the exponent must be positive. So as long as you got the exponent positive, you have your full marks. And then now this one also, we have it as negative, so we want to make it positive. So it means since it's a numerator, it has to become a denominator, so then it's gonna go down as well. So then this is gonna be, so it just joins the denominator. That's what happens, right? Yes, so that's what happens. So that then we have it. And just before I do the fifth one, if you enjoyed my video, please like and subscribe to my channel so that you can receive more things like this. Okay, let's look at the final example of this video. So they say find the derivative of y with respect to x if y is equals to 2 square root of x cubed over 3 plus 4 over 5 cube root of x, right? So of course this is not in a differentiable form, and we've got radicals, so we can choose to first change radicals into non-radicals. So let's do that. So we still keep it as y because we are still manipulating, we're not deriving. So from there, this is gonna be x 3 over 2. What is inside goes on top, but what is outside, which is an invisible 2, goes down. And this will be all over 3. And then let's change that as well. So now we're gonna have 4, and then we're gonna have 5. Now this is cube root of x, so whatever is inside, which is an invisible 1, goes up, whatever is outside goes down. So there we have it. Okay, so this is what we have so far. Okay, so let's go forward. So we're still keeping it as y because we're not deriving, it's not in a differentiable form. So let's put this into a differentiable form. So this is on top, we just have to shift it on the side, which is still the same as it being on top. So from there we don't have to change the sign. And then this one, well, this one is still is down, so we have to shift it on the side, which is changing it from down to on top. So whenever something changes from numerator to denominator or denominator to numerator, the sign of the exponent changes. So then this is going to be 1 over 3, negative 1 over 3. So now it's in a differentiable form. We've got coefficient, variable, exponent. Also here, coefficient, variable, exponent. And then from there, now let's go to the step of deriving. So now let's derive. So when you derive, it's going to be derivative of y with respect to x. Then this times 3 over 2. The 2 will cancel the 2, the 3 will cancel the 3. Whoa. So then this is just going to be x. Okay. And then this side is going to be negative 4 over 15. And then minus 1 over 3 minus 1 should be minus 4 over 3. So there we have it, right? We get our full marks, but let's just say the question says leave your answer to positive exponents. So let me just rewrite this step. Alright, so here's the rewritten step. So now we have to leave the exponent, leave it to positive exponents. So then this derivative of y with respect to x equals to x. There's nothing to change there. So now this is negative exponent. So since it's on the side, it's the same as if it's up. So since it's up and we want to change the exponent, it means it has to change from the numerator to the denominator. So from there, it means there is no choice but to go down. It has to join the denominator. So then this is gonna be that. So there we have it. Alright, check out part 2 of the video where I deal with dx and we have brackets. I will also include that in the description below.